Okay, now we will start with a new topic, dipole. So how dipole can be defined? So the combination of two equal and opposite charges kept very close to each other are known as electric dipole. Meaning of this, suppose one charge positive Q, another minus Q. When these two charges are kept very close to each other, so this set of two charge can be said as electric dipole. So what is the physical significance here in this particular point or in particular electrostatic chapter? Whenever such type of situations are given, such type of situations means the two charges very close to each other. So rather determining the electric field at any point or electric field at any potential at any point or field at any point, rather calculating due to individual charge, we can calculate by considering the set of two charge as a system. So this is the advantage. So first, to define the electric potential or electric dipole, first very important point is the dipole moment. Dipole moment, this is a physical quantity we are defining and with a capital P, and it is a vector quantity. So it is defined as it is the product of one of the charge of a system and distance between the two charges, and distance between the two charges. It means if we are looking for the above diagram, so dipole moment P is defined as Q into L and N cap. N cap gives the direction. So important point here regarding direction. So direction of, first point we can say, direction of dipole moment is from negative charge to positive charge, along the line joining two charges. It means this is positive charge, this is negative charge. If this is the line joining two charges, so direction of dipole moment will be this. This is the very important point for dipole moment. Second point we can say, the SI unit of dipole moment is from here, Q coulomb meter and is coulomb meter, and its dimension of P is given a dimension of charge dimension of charge is AT and dimension of length L. So dimension is given as ATL. These two are the important point regarding dipole moment. One is the direction of dipole moment. Direction of dipole moment is always from negative charge to positive charge along the line joining two charges, and dipole moment is a vector quantity. Similarly, and second point is the dimension ATL and SI unit Coulomb meter. Now see the one question based on the dipole moment. Now see one example. The system of charge given as shown in diagram. A system of charges shown in the diagram find the dipole moment of a system. Find the dipole moment of system like this. Let here minus 2q charge and here minus q, and this is your plus 3q, and all these charges kept at the corner of a equilateral triangle. Question like this. It means a system of charges, there are three charges are given, minus q, minus 2q and plus 3q, and these charges are kept at the corner of an equilateral triangle as shown in diagram. Now we have to find what is the dipole moment of system of charge. The first thing is that, so as per the definition of dipole, the net charge in the dipole is always 0 because two equal and opposite charges are at a certain distance L. Here, see, in the whole system, if we are talking about the net charge of a whole system is 0, it means we can have a combination of some dipoles. How we can say here, plus 3q charge we can split into two parts. One charge we can have this plus q, we can divide plus q and 2q. So this can be made like this. This is your minus 2q minus q. Here we can divide plus 3q into two parts, plus q and plus 2q. So what can be said here? This 2q and this minus 2q become one dipole, and this plus q and this minus q become another dipole. Here it is not mandatory if we should make that type of dipole. We can have any such combination. Even you can write here minus 2q and plus q. So plus q and plus q, or minus 2q and minus plus 2q, you can make any set of combination you can take. So this is your one dipole, and dipole moment direction is this, from negative charge to positive charge. Let P1. This is another dipole from negative charge to positive charge in this side, that's your P2. And these P1 and P2 are making an angle 60 degree. So see, P1 is equal to your 2q into L, and P2 is your q into L, and the angle between these two vectors is your 60 degree. So if we want only magnitude, the resultant dipole moment is given as P1 square plus P2 square plus 2P1 P2 cos 60, and here substitute the value of P1 P2. So P1 means here 2QL whole square plus QL square, and this cos 60 here 1 by 2 cancel, P1 P2 become your 2Q square L square. It become your total 7Q square L square. This is root 7 Q into L. This is the resultant dipole moment, and after that we can get the direction also. So this type of question can be asked related to the system of charges, and the whole system of charge act as a dipole, and this is the dipole moment. Now see the next point, electric dipole in electric field.